Okay, class, we're about to start section R 3.10, regression, recap, linear, exponential, and quadratic. On page 164, it gives vivid descriptions of the different type of graphs and also their equations. You can look this over at your leisure, and if you have any additional questions, feel free to ask them in class. Okay, now, we go to page 165. Now, we have here example 5. It says the FBI calculates the burglary rate every year. 3 different scattergrams are with 3 different models and R-squared values given. Now, if you look here, you notice here, look at these equations. This is a linear equation. This right here is this is an exponential equation, and this here is the quadratic equation. But we're also given the R-squareds of both of those equations. Now, we look here, we look at the R-squared. We're looking at the relationship between the points and also their equations. If you notice, this graph here, which is the quadratic, has the strongest relationship at 0.9674. So you would get more accurate results when you use the quadratic equation. So now, we scroll down here, it says label each graph as linear, exponential, or quadratic. So we know that this is quadratic. We know that this here is linear. And this here is exponential. Now it says, according to R-squared, which model fits the best data? And that would be the quadratic. And then it says, explain. It has the strongest relationship. Which model will make the best predictions beyond t equals 22? And that would be quadratic. And that is because it has the strongest relationship. Okay, now, we go on to the next page. It says, fill in the table below. It says here, best model explained, best fit for the current data, best fit for the future prediction, write the function in its R-squared. Now, basically what is happening here is you would need to enter these in. This says since 1980, this has 1990, this has 1980. And then the next graph has 1980. So basically what you would do is this here. You look at these graphs here. You know that you have to use linear here. You use exponential here. And then you also will use quadratic here. Now, basically they want you to try all 3 though. So you would put all of these values in with the proper L1 and these values, and then you will find the linear regression, the quadratic regression, and the exponential regression. And you would get all of those values and put all of their equations here and also their R2s. Does everyone follow that? Now, I cannot show you that because, like I said, I do not have the emulator calculator, but you all know how to put this in your calculator. So you all can put that in your calculator. Now, it gives a warning here. It says almost always a quadratic model will have a higher R-squared value than a linear model for any data set, but it is not practical for predictions and other applications. Look at the scattergram, and if the data are not forming a definite curve, the linear model is probably best. So basically what they're saying here is this. The quadratic model, of course, is always going to have the stronger relationship in most cases. But if you look here at the graph, you do not see any type of curve here, really, right? This would best be a linear, most likely a linear model, as opposed to a quadratic model. Now down here, it gets a little trickier when you're dealing with the exponential model. It says sometimes it can be hard to discern if a graph is exponential or if it's merely half of a parabola. Because this could actually be a parabola. It could, basically go like this on the other side, right? And we just don't see it. But it says in general in Math 131, if the data form a classic exponential curve, then the exponential model is best. So basically it's saying for this class only, if you see this here, most likely it's an exponential model. And then we come here. Very often real world data does not form a clear pattern. Instead, the data are more scattered. If the data are not curved and form a general increasing or decreasing trend with no arc or curve to the points, a linear model is best. So if you look here, there's no curve, arch, or anything like that. So it's basically telling you to use a linear model. Does everyone follow that? Okay. Now, and this is basically it. Note, these are just a few of the issues that can arise with fitting models. There are also many other possible models that are not covered in this course, but are in the calculator and Excel. And that's basically it from this.